Hi Pranjal.
Hi Jagrati. Hey everyone, Randall this side. I hope you are able to hear me loud and clear. And in this session, we're going to explore that how. So in this session, we're going to explore that how we can run the containerization applications on Vultr platform. So it's super easy. Bef- Before we move forward, just give me a second. Hello. Okay. So we are live again, and over here we're going to explore. Yes. Okay. Sorry. My bad. Actually, two videos were running at the same time. That's why I was getting my voice back. So no issue. So yeah, here we go once again. And before we move forward, let me share our GitHub repo, which you can use throughout the session. Okay. So in this GitHub repo, you will going to find our codes. You are going to find our the PDF files, the commands, whatever resources required for today's session. You're going to get each and everything over here. Okay. So now, firstly, we before having our hands-on session on this Docker and related stuff, it's very much important to understand what exactly Docker is and what is containers, and it's super easy. So if you go in one of our GitHub repo, if you're going to see the PPT over here, okay. So the very first thing which you should be aware of, what is container, okay. So container is like a very lightweight, standalone, executable software package that includes everything. Let me explain you with the help of with whiteboard. It's super easy and you'll be able to understand very clearly. See what happens a lot of time, like in order to, you know, uh, run application on cloud, you need a server. Okay. Now the server, like the virtual machines, we need them. So for in order to set up the virtual machines, it takes time. There's other lot of problem which we have with the virtual machines. But what we can do with the help of containers, we can omit those problems. Okay, let me just explain you what exactly the container will going to be like and how it is different from virtual machines. So for example, this is the server, okay, and this is our client. Okay, now client is making the request to the server and where your application is hosted. Okay, this is as simple as possible. Okay, now the thing is like, if there's a need to scale up your applications, okay, so there will be a chance like when your server is not capable of scaling up your application, you need to add some more virtual machines in order to scale up your applications. Now over here, for each and every virtual machine, you have to load the guest operating system, which takes time to get loaded. So there's so many things which can create the hurdle for your application performance. So in order to avoid the situation, we have something known as container. This is one of the reasons why we should use the container. Let me also cover the other reasons as well. Now, for example, your server is having with Python installed and with some 3.7 version, something like that, and some other packages and frameworks are installed. Okay, now in your system, you're the developer. Okay, you are the developer, and in your system, you have the Python with 2.7, I think so, or whatever version you have. No, just because there's mismatch in version, there will likely chance that there will be mismatch in the code as well. Like for example, in 2.7, we write raw input in order to collect the input from the end user, whereas in 3.7 we just directly write input. So a little bit, code difference will going to be there. Now just imagine, this is just talking about one single programming language. Okay, you have other frameworks, you have a lot of things all together. Like if you're working on some complex workload, you're not only limited to just one programming language. There are a lot of programming language involved, database involved, libraries and packages are involved with different package with different versions. Now you have to make sure whatever you have in developer machine, you have to same in the server as well, so that whatever application is running at your end, it should be working on the server end. And sometimes it doesn't work. That's why there's one problem which is very, very much popular in our DevOps space, which is it works on my machine. So this is the reason. And how to fix that? What you can do, you can simply pack your application and then run that application with the help of container on servers. Now this container which we are talking about, this is very much interesting. Just like the containers look like in real world, like in the real world containers, we're going to have everything. Like they can take the things like you ship the car, you can ship the any other devices or whatever, and then from one place to other place they can be loaded very quickly. Okay, so Docker work on the same paradigm. Okay, like over here this says like code, or you can say build, ship, and run. Okay, so this is what the Docker bet on. So you have to just focus on building your application. You don't have to worry about the configuration, whatever we need to set up in the server side. You just have to focus on the development side. Once you are done with that development work, what you can do, just put all those stuffs, okay, your applications, your libraries and packages, every single things, just put them all together into a container. Now you can run this container literally anywhere. Now just imagine like you build some application and you want your peers, your friend, your team member should test your application. So in that case, what you can do, you can just simply ask them to download your Docker image, and from there they can run the Docker container. It's as much easy. Your friend, your team member doesn't have to install Python and other packages which is required for running your application, because all those stuffs which is required by your application, it is already there into this container. This is what container meant for. Now let us revisit the definition of the container. What is container? It's a lightweight, standalone, executable software package that includes literally everything needed to run a piece of software, which includes the code, runtime, system tools, system libraries, and a lot of other settings. Okay, this is a two image which you can see, and you can clearly understand the difference between the virtual machine and the containers. In virtual machines, you have the hardware layer. Of course, you have the hardware layer. Then you have the host operating system. Then hypervisor is the responsible for creating the virtual machines. Okay, and then you can load your libraries and packages, and of course you can run the applications. Okay, this is the case of virtual machines. Now in the case of container, what happens, we have the same hardware layer. Of course, we need the hardware, and then on top of that hardware, you have host from system so that you can communicate with the hardware, the kernels, and all those stuffs. And then on top of it, you got the Docker engine. Okay, now with the help of Docker engine, you can create the containers. So this is container 1, container 2, container 3, container 4, 5, and 6. We have the same capacity, same hardware, but over here in the case of virtual machine, you can just run three virtual machines where you can literally means three applications you can run. Over here you can run multiple applications all together. So the proper resource utilization is happening, because in the case of virtual machines, you have to create this guest operating system, this extra layer, which is consuming a lot of resources of your hardware. So we don't need that. We only need our applications, okay, and their libraries and packages, and the rest of the thing will going to be taken care by Docker engine. Okay, so over here, the containers are very much good in resource utilization. They are fast to load because they are very much light in weight. They can scale very easily because again they need, they have proper resource utilization. They can scale very easily and just very quickly as well. Just because of lightweight again, it provides the proper isolation as well, and it's easy to port it as well. Okay, so this is the difference between virtual machines and the container, and how container is better than virtual machine. But this is not what you have to think around. Like we have to always use containers. The solution which we work in real world scenario, we use the combination of virtual machine with container, and in this today's session we also see that part. So today what we do, we will going to create the instance on Walter platform, which is a virtual machine, where we can set up the Docker stuffs, and from there we can run the container. So at least you need one virtual machines where you can actually load your containers. You cannot run the containers directly. So you need some space, and that space we're going to do it with the help of Walter platforms instances. Okay. Now over here, what is a Docker? Now Docker is a open source platform which help us to create that containers. Okay, where our applications are running. Okay, so Docker allows application to be packaged with all their dependencies into that isolated unit, which is known as containers. Okay, I hope till here everything is clear to me. What is virtual machines, what is container, and difference between them, and how a container gives some better benefits, as compared to virtual machines, and what is container, where your application is running. Okay, now there's few more terms which you have to aware of, which is Docker image, Docker file, Docker container. Docker container we have already covered, and Docker hub. So Docker image is a read-only template which is used to create the Docker container. So for example, we know like this is our container, okay, and the container having our application. We know this, okay, and not only application, all the libraries and packages which is required, packages framework is there. Now, in order to run this container, we need something, and that something is Docker image. Okay, so we need a Docker image to create that so that your application is up and running. Okay, now this Docker image, now you might be thinking this is getting a little bit confused. We got to know what is Docker container. Now what the heck this Docker image is? Now let me just give you a very simple analogy to understand. Like you got the .exe file in Windows specifically, and which whenever you will going to create click on this executable file, it will going to create some task, or we can say a process. Okay, now over here let me show you with one example. If I just go and open a calculator, and this calculator is basically, just give me a sec. Over here I can just simply open, this is a executable file, and after clicking on that executable file, it opened the calculator. Now if I go to the task manager, you will see there's one process is up and running, that calculator process, and as soon as I will going to end this task or the process, that will going to be get deleted. Okay, so the executable file is basically, you can think of as a Docker image. Okay, is a template, is a, you know which contains your source code, the libraries and packages, and all those stuffs. Now this Docker image will going to help you to create the containers. Okay, so you can just understand side by side what exactly that Docker image is and Docker containers are. Okay, so the exe file which we have, the executable file, okay, a kind of, template file which you can think, and whenever you will going to click on this executable file, it will going to create some task and process. Okay, and the Docker image is again the template, okay, which contains everything about your applications. And whenever you're going to use this Docker image, it's basically going to create a Docker container where your application will going to run. Okay. Now you might be thinking, now I got to know how to create a Docker container. Now, how the heck this Docker image and how I can create it? Okay. Now this is something else which you have to focus on. There's a one instruction file there's one instruction file where you are going to mention everything, like where you will going to give the all the information about your application, what packages are required, at what port your application could be accessible, and what are the environment variables. There are so many things which is required. Okay, so the Docker container where your application will going to run, and that is created through the help of Docker image, and the Docker image is basically a template. Now, in order to create the Docker image template, we have to provide all the instruction to build that. So, like in our case, I will going to use the Python Flask application. So I just have to mention like I need Python install, okay, and then the libraries which I will going to use, which will be Flask, okay, and then other than this, I'm going to mention like my application is accessible at port number 8080, something like that, and of course we need our code. Okay, we need our source code of our application. Okay, so this four things I have to mention into that instruction file, and that instruction file is known as Docker file. Okay, so now I hope now this four terms are not clear. Okay, we have to cover Docker Hub as well, but yeah, as of now I hope these three terms are clear. What is Docker image, what is Docker file, what is Docker container? Let us read it once again. Docker image is a read-only template which is used to create the Docker container. Okay, Docker container is a place where your application is running. It creates that environment to run your application, in the right way. Then what is Docker? What is Docker container? Docker container is a runnable instance of the Docker image. Okay, and that instruction file which we talk about is known as Docker file. So Docker images are built from a set of instructions defined a text file called a Docker file. The Docker file contains the configuration and dependencies required for the application. Now, images are stored in a repository, and that is known as Docker Hub. Okay. Now, after creating, you got the application. Okay, you got the application. Let me just write it down. You got the application. After building the application, what you did, you have created a Docker image, and after that, you have checked that your Docker containers are up and running or not. Okay, you have checked everything. You got the application, you got the Docker image, and you got the Docker container, and of course Docker file is needed to create the Docker image. Okay, so you know all these stuffs, we have seen that far. Now, in order to share your work, your Docker image, okay, because right now that image is there locally, it's not share at some center place where from your team members, your friends, or your server can access your container, sorry, access your Docker image. So we need to put it somewhere, some remote place. Okay, and that remote place is known as Docker Hub. Just like we have GitHub, where we put our source code, in a similar way, we have the Docker Hub, where we put our Docker images. Now, your friend or your team member, what they can do if they want to run your workload, your application, they just need only Docker installed. Okay, and after having Docker installed, they can just simply pull your Docker image from Docker Hub and then create the container from it. This is so easy to work with these containers. Okay, now your friend doesn't need the Python event to run your Python application. This is what a beauty around the Docker containers and Docker. Okay, this is the whole steps. We have to build the application, write the Docker file, build Docker image, run the Docker container to test that your image is working fine or not, and then push it to the Docker Hub. Wow, this is what a general Docker workflow is going to look like. Okay. Now, before we move forward, also let us explain how the Docker works. Okay, some more components of Docker, so that it will be easier for you to understand. And if some sort of things happen between, some errors are coming in, you can know how to deal with that. Okay, so you should be aware of that how Docker works. So, for example, if you write in this way, like Docker run hello world, so this is let me just explain it in a much more better way. Let me just snap it, this particular diagram, and put it on my whiteboard so that I can use my uh, yeah, I can use my pen to explain you much more better way. So over here you can see one thing, that here is something known as client and there's one thing known as host, or you can say a Docker daemon. Okay, Docker daemon you can think of. So just Docker daemon is basically, you can think it as a Docker uh, engine. Okay. Okay, or sometimes what you can think of this whole thing as a Docker server. Okay, just in layman, I'm just explaining in a very layman way so that you can easily understand that how this Docker works. Now you know this diagram. You got the client, you got the server. Client is making the request, and server is responding to that request. Okay, this is what the client server architecture looks like. So Docker client is a place where we give the instruction to this Docker server or Docker engine, like, hey, I need to run this hello world image. Okay, I want to run this hello world image. So what happens? The Docker, there's a server, will going to process your request. Okay, we need to run this image, we need to create the container. Okay, so once getting that request, after processing that request, they will going to find that hello world image locally. If that image is not there locally, then they have to pull that image, they have to pull that image from the remote registry. Now that remote registry can be a Docker Hub, or it can be a Vultr repository as well. Okay, so Vultr also provides that container registry as well, where you can put your Docker images. Okay, so in our case, we're just going to use the Docker Hub, but yeah, you can also use a Vultr repo as well. Now over here, the Docker Hub is a remote place where you have kept your Docker image. Now, if you want to run this Hello World thing and Hello World is not installed locally, then what happens? It will going to pull that image from this Docker Hub, and once it pulls successfully, then it will going to create a container. Now, the next time again you have that need to run this Hello World Docker image. In that condition, what happens? Just give me a minute. In that condition, what happens? Uh, it will going to directly create a container locally, because that image is already there, stored locally. This is how it works. We're going to see this example in hands-on. Okay, so let us do one thing. Let us set up, let us set up our Walter platform where we can actually run the Docker containers. Okay, so this is how it will going to look like. Okay, so over here we got the option, just click on deploy servers. I hope this is already covered in our past sessions, but yeah, I'm just going to show you that how you can do that. So over here the four options comes in, you have to choose one of them. And if you're going to choose the dedicated CPU, so it is dedicated for only for you, so of course it will be expensive a little bit. So what you can do, you can go with the second option, which is the share option. So you can see that how much price get dropped, and if there's need of any GPU or a kind of bare metal, well, the platform also offers such kind of things as well. But for right now, for our use case, I will going to choose this shared CPU option. Okay, now you have to choose the locations. Right now I'm nearby Delhi, so just going to pick this Delhi option. And you can choose the other regions as well. I think 32 regions they support, so you can choose accordingly as per your need. Okay, now over here you have to choose the image. Okay, so over here we're going to choose Ubuntu, one of my favorite Linux distros. Okay, you can choose other or OS as well, but right now I'm just going to go with the Ubuntu one. And you can see still the charge is around $14, 40. So now, because in our case we don't have to have the high compute capacity, high frequency, and high storage capacity, we don't need such things. So what we're going to do, we're going to choose this one. This offers 1 GB memory, 25 GB storage, 2 TB bandwidth. This is more than enough. So I'm just going to go with this option. You can see how the price get dropped from $14 to $7, which is just half of it. Now after that, I will also going to remove this thing as well. Like, we don't need the auto backups because we are just running for a short period of time. We don't need this one. So I have removed this thing. So it decreases $1.20 as well. So from 7 to it goes to $6. Okay. Now after this, if you're going to scroll down a little bit more, yeah, there's an option to choose SSH keys. I've already created the SSH keys and super easy. Okay, let me show you if you don't know how to create one. So you can just go to this manage option, and over there they have share one instruction which you can do that. Uh, just give me a second. Yeah, over here. So this is the instruction which they have provided, which you can use it in order to create SSH keys. So if you are on Windows, then sorry, if you are on Linux, then you can use this SSH keygen. Okay, and if you're on Windows, then you can you follow the steps with whatever they have provided with the help of Putty, which is a kind of application which will going to is a kind of utility which can help you to create the key pairs. Okay, and this is some other important troubleshoot steps are also mentioned which you can go with. Okay, now I've already created one of the the key. Okay, this is a key, my private key. You can see very clearly how it's gonna look like. Open with and notepad. So this is a private key, you can see open ssh private key, and this is what the public key will gonna look like. So as soon as if I'm going to select this option, this option, my ps test, because over here I've already given my public key. Okay, we need both the keys. It's kind of asymmetric encryption, so we need to provide both the keys. Okay, one is public and private key in order to successfully connect to our this instance. Okay, compute instance. Now, in our case, if you want to have some firewall group, you can also do that. But right now, I'm just leaving it empty, and it's going to give us public access. But if you need some more restricted, some rules to set up for firewall, that which traffic can goes to your instance, which traffic can goes out to your instance, you can do it from here. Okay. Now you can just give any name for your server. So I'm just going to give GFG Walter and GFG Filter, or let me just write PS. Okay, now you can just click on deploy now, and wow, they're going to create an instance for you. So right now, just installing everything, which is in the initialization phase, and we have to wait for a moment. And once it is up and running, we're just going to connect our instance with the help of that keys what I've talked about through the CMD. Okay, through the command prompt, we're going to connect to our instances. Okay, so what we can do, we can just go inside and just give me a second. It's gonna take a little bit time. Once it is done, you can see it's showing or running. So it also given us a instruction like your server may still be finishing installing and booting up during the first few minutes of activation. If server does not ping, you can view the console to monitor the progress. So you can just click on view the console, and here you can see it is failed to connect. So because right now it's still creating. So we just need to wait for a moment. Once it is ready, we can actually connect it. Okay. Now let me just click on vConsole. So your instance is currently being deployed, so it's still not ready. So we have to wait for another minute, and once it is up and running, we are able to access our instance where we can actually run the the Docker workload. Okay. Meanwhile, what we're gonna do that. Uh, this is our application. Okay, and this application is very easy. Let me show you how our application will going to look like. Let me just write rp slash script activate and then rp. So this is a virtual environment which I've created in my local system as well. Now over here, I'm just going to write python app.py, and after doing this, we're going to run the application. Okay, so if you see, I'm going to open this particular URL. You can see this is how our application is going to look like. Namaste everyone. Okay, so this is what our application is going to look like, and this is what we're going to do. We're going to put this application inside the container. Okay, so it's super easy. Firstly, let me just close this application which is running right now. Okay, now let me just do one more thing. Let me just open the Visual Studio Code from where we can just explore other files as well altogether. So over here you got the app.py. This is what we have opened, and our application is accessible at port number 8080. So you have to remember, you have to give this instruction in your Docker file, the instruction file. So inside the Docker file, you have given like I need the Python to be installed, and then you have to provide your source code. So what I did, like copy and then the current directory, and I created one folder inside my container slash application. So all the things what you're seeing right now, this whole things goes inside the application folder, and then I switch to this application folder and then install the all the libraries and frameworks which my application needs. Okay, and then expose the port number 8080, and then I just want to run it python app.py. This is what I want to have. So we have to just run a simple command to build the Docker image from here. So just write docker build -t, and after writing docker -build -t, you can just write my Walter app, something like that, and then dot where your Docker file located. So it is there into my current directory. Now it says that Docker daemon is not running, so you need to run your Docker engine. So make sure you have the Docker desktop installed if you're using the Windows. Okay, if you're using the Linux, so you have to install Docker with the help of some few commands. I can share that commands as well, which you can do that. Or right now, like the Volta platform which we are creating right now, over there we're going to set up the Docker as well. So you can just look into that, that how you can configure Docker and Linux environment. So it's super easy over there as well. And Windows especially is super easy. Just you need to install this Docker desktop. You got everything. You got Docker client, Docker server, everything is up and running, up to the mark. Just you can directly use it to work with this Docker thing. So it takes some time to get started the Docker engine. Once it is done, you are ready to create the Docker image, to build the Docker image from the Docker file. So let me just again revisit this Docker file to show you what exactly it meant for. So you have from Python latest, which is a kind of base image, and this base image comes with Python already installed. Okay, so it's a base image, just like a minimal operating system where the Python is already installed, and then you have to copy the code to your application folder, which is inside my container. Okay, and then I switch to the application folder, and then I will gonna run this particular command to install all those libraries and packages, and then expose my application on port number 8080 because this is where I can access my application. Okay, and then the I have to just run python app.py to actually run my application. Okay, so you can see it is up and running, and meanwhile let me just delete a few images, which a few container which I already having, and the images as well just want to delete. Okay, okay, now over here what I will gonna do, because you can see right now we don't have any image. So what I was gonna do, previously we were getting the error, but now if you're going to run the same command once again, and this time start building the image. Okay, so it won't take that much of time. Once it build the image, you are ready to create the containers. So as I can see, we have successfully created the image, and I can see my Walter app is coming over here. Now let me see that how uh, this image will going to look like. Okay, the container will going to look like. So just write docker run -it -p 8080. Okay, and 8080, and the name of your image, which is Walter app. Oh, my Walter app it is. My Walter app. Now it's just going to run the container from that image. You can go to this container option, and from there you can just see that it's up and running. Wow. So we are able to access our application which is running inside the container. This is how this container works. So what we did, we got the application, we use the Docker file to build the Docker image, and once it is done, we created the container out of it. Now the next step which we have to do is to push this Docker image to the Docker hub. Before that, what I will gonna see, yeah, what I was gonna see, that our Volta instance is ready or not. So let me just refresh this page, and then I can just go over here, view console. So now it is up and running. Wow, perfect. So over here, just write root, okay, the default thing, and also they're just going to share you some password which you can work on. So this is what you have to write in. Just give me a second. Let me just write it over here. So either I can do it with the help of CLI as well, but right now I just want to show you that how this is going to look like. So this is going to be hidden because it's a password. So uh, just give me a second, and once it is we have provided the right password, it will gonna run. Wow. So I given the password, and you can see we got that successful message. So we're inside our Walter instance. You can see we got some message like welcome to Ubuntu, and this is some documentation stuff, the systems related information, the load average, the memory uses, the swap memory uses, the processor, and the user logged in. So you got some rough informations about your system and some more informations over here. So this is our Walter platform instance. Okay, now over here we have to set up the Docker. Now let me show you that how you can configure Docker over here. So you have to just clone my GitHub repo, which I have shown you in the very beginning of the session. Just go over here and copy this and then paste this. Okay, now the pasting is not working. So let me just do one thing. Let me just close this console for a moment. And what I will gonna do, what I will gonna do, I'm just going to copy my IP address, and then I will gonna open the command prompt over here and just write SSH. Let me just zoom in a little bit. SSH -i and then my private key, and then root. This is my username basically, and then the IP address. Just do this, and yes, and you are successfully connected to your remote instance, the Volter instance, with the help of SSH. Okay, with the key whatever we have created. Now over here, what I will like to do, just write git clone and the URL. Oh, sorry, we need to again copy the GitHub URL from here. Voila. Now, after doing this, we got our GitHub repo over here. So let me just get me into this repo. Now over here, I have to install the Docker. So just simply write sudo sh docker.sh. This particular file contains, um, the all the steps which is required to install the Docker. Okay, so firstly, we're going to update your Ubuntu and then install some other libraries and frameworks which is required for the Docker. And then at last, if we're going to install the Docker, and then if we're going to enable the Docker stuffs. Wow. So it won't take that much of time, you can see, and it's running. And once it is done, you got everything. You got Docker engine running on your Volter platform instance. Wow. Now over here, meanwhile, what we have to do, you can see we are able to access the container as well. So let me just do this thing. Mhm. Okay, everything's done. Everything. Okay, let me just write Docker over here. Wow, it's working. Let me just write Docker version. Wow, everything's working. Now what are we gonna do? I'm just going to run a very simple command. Okay, which is Docker run hello world. Okay. Oh, sorry. Hello world. So over here, if you see this image, which I've shown you in the very beginning, is Docker run hello world. This is the exact command which we are trying to run. Okay, and after running this command, because we are using the CLI, and this client is where you're going to give the instruction to the server, and then server is going to look after your request. So if this image, this hello world image, is there locally, then it will going to create the container very quickly. But if it is not, it will going to pull that image from Docker Hub, and then it will gonna run the container. Okay, before that, let me show you one more thing. If you go to this Docker Hub, oh, here's Docker Hub. Okay, now this is the Docker Hub where you can find that hello world image. Okay, let me show you. Oops. Go to the Explorer, and after going to the Explorer, just write hello, and you're going to get the hello world image. Oh, I just need the Docker official published image. So this is the hello world image which I'm talking about. So this is the image which will going to pull it from the Docker Hub. Okay, and from this image we're going to create the container. Wow. So I go over here, just write Docker run hello world, and then hit the enter. So it says unable to find that is this image locally. As I mentioned, if the image is not there locally in the local registry, if you're going to pull that image from remote registry, in our case, it is Docker Hub. So when it pulled that image, pulling works over here, pull got completed, and then it just printed this image, this message. This message says hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. Docker client contacted the Docker daemon, the server. The Docker daemon pulled that hello world image from the Docker Hub. The Docker daemon created a new container from that image, which runs the executable that produces the output which you are currently reading. And then Docker daemon streamed that output to the Docker client. This is our Docker client basically. Wow. So this is very easy to do that. Now, if I were going to run this command once again, Docker run hello world, let's see what happens. Wow. It doesn't take that much of time to pull that image from Docker Hub. And we don't have that message, okay? That message which we got, like unable to find this image locally. This time we didn't have this message, which means now this time the container whatever we have created, it taking the help of the image which is already stored locally, and from there it just created the container. This is what it works. Now we have created our image. Okay, my Volter app, let me just go over here. We have created this Docker image, and we have seen the Docker container is also working fine. Now what we need to do, because we want to run this image to our Volter platform instance, so what we have to do, we have to put this image to the Docker Hub. Okay, so that from there we can pull that image to show you that how this will gonna work. Okay, so let's do this. It's super easy. You just need a Docker Hub account, and it's super easy. Let me show you how you can do that. You can just go to the Docker Hub, and then you can just click on over here and create the account. It's very easy, just like creating any social media account. Okay, sign up, just provide your email address, the password. This is the rough stuff which you have to do all the time. Okay, so over here, once you have created the Docker Hub account, what you have to do is to create a repository over here. Okay, you can just go over here, click on create repository, and then you can just write my Walter app. Okay, and then you can, if you want to give some description, you can do that. Just click on create. Okay, so over here we need to run these commands. Okay, so what we have to do, just write docker tag. First of all, I have to write my name, my Walter app. Okay, docker tag my Walter app and the name, which is this. Now you might be thinking, why, Pranjal, you are using this tag command? Now, before the tag command is very much required, because here it says docker push psrv3 slash my Walter app. Okay, now this image doesn't exist. Okay, this image doesn't exist. After running that tag command, it created this, a new thing. Okay, so now what I can do, I can just simply push this Docker image to the Docker Hub. Okay, let's do that. Docker push and then psrv3 my Walter app. Now if we're going to push our image which is stored locally to the Docker Hub, okay, and then we're going to pull this image to our Walter platform instance. It won't take that much of time, just we have to wait for a moment. Once it is done, we are ready to see that. So right now you might be thinking, why is it taking time? You said, Pranjal, Docker is very fast. Now the thing is, like, here I just use the latest, which is not the recommended thing. I'm going to show you that how you can optimize the size of Docker image, because if you see the size, which is 1 GB, which is not a good image. Okay, the size should be under 100 MB or 60 70 MB, something like that. So I'm going to show you that how you can do that, how you can decrease the size of your Docker image. We're going to see that thing as well before ending the session, so nothing to worry about. But yeah, right now you can see our image got created. We created the container from it, and it's working perfectly fine. Now we are pushing our Docker image to the Docker Hub, I think, which is already done. So you can see right now we don't have any image. It says it is empty. So if you go to refresh this page, you're gonna have the Docker image over here, the one which we have up, push to this Docker Hub. Now I'm just going to use this image into our, Walter platform. So I go over here once again to our Vultr platform. Okay, now over here, I'm just going to write docker run hyphen it hyphen p 8080 and then name of my image, which is psrv3 slash my Walter app. Now here it goes. It says unable to find this image locally, because of course it is not there stored locally, because it is in my Walter platform instance. Okay, we are running this image for the first time, so it's just going to pull this image from the Docker Hub, and once it is done, it will going to create a container. So we need to wait for a moment, and once it is done, you got your application, your container running on your Walter platform. So you can see it is up and running. Okay, now let me just do one more thing over here. Let me just press Control C. Over here, I'm just going to write hyphen D. Okay, docker run hyphen itd. Okay, and then this whole thing will not going to become. Okay, so now this is running in background process. Okay, so clear. Now, in order to access your application, which is running to your Walter platform, what you have to do, you have to go over here, and you have to look for the IP address, which is this one, 139.84, whatever. You have to just copy this, and you just go over here, paste that URL, and then on which port our app is accessible. Is port 8080. So just write that port, and yeah, your Docker container is up and running into your Walter platform instance. So I changed a little bit. Instead of hello, we just mentioned namaste, what we call it in India. So namaste, everyone. And over here, this is what you can do with the help of Walter platform. Just have Docker runtime into your Walter platform instance. That is only required. You don't have to install Python even. You don't have to install Flask even. Just that Docker image is sufficient to run your application. This is a very simple application which I have built, but the complete application will going to have a lot of packages, a lot of frameworks, which you don't have to worry about. Just and on that developer machine, of course, we have to install that stuff. And once you build your application, and then you create the Docker file, and then you build the Docker image and upload it to the Docker Hub, And from there, if anybody tries to pull your Docker image, they don't need any packages, the frameworks which your application needs them. They only need the Docker runtime, which I have shown you in this World Platform instance. We have the Docker installed. That's it. Now I just pull my image and it's up and running. I had not installed the Python event, nor the Flask the library. It worked perfectly fine. This is the power of Docker. I hope you can understand from here that how Docker is going to eliminate a lot of problems. The problem of configurations, okay? Because there's a trap of configurations. So if you change in this, you have to change it everywhere. Okay, now just imagine because in real world you don't have only one single machine where your application is running. Okay, you got multiple servers where your applications are running. Okay, now if you make a simple minor change in library and framework, you have to do it to every other machines. Okay, so this is how you can avoid the situation taking the help of Docker. Okay, you just need to have Docker installed in all the machines, and whatever images you have, they will going to pull that image and then run the container out of it. So over here, let me again revisit. Today we have explored what is virtual machine, short thing, and then we have explored that what is container, and then what is Docker. Okay, Docker is a platform which is going to help you to create this container. Okay, and then other than this, we have explored the that how Docker works. Okay, and we have explored the important stuffs, important concepts around Docker, which is Docker image, Docker container, Docker file, and Docker hub. Okay, these four things are very much important to understand, and which we saw that. And we have also configured Docker runtime to a virtual platform instance, and then we have pull that image which we have created, the custom image which we have created, pull that image to the virtual platform instance, and from there we have created the container, and then we access our application, our container, which is actually running inside a virtual platform instance. Wow. So this is what we have covered so far and within 1 hour session. And now the question is how we can decrease the size. Okay, because this is something which may be very much important, and because we have understand like they are resource efficient thing, so we have to decrease the size from 1.05 GB to some, you know, some size smaller than it. And how we can do that? Just choosing the right base image. Now if you go over here, over here I have used the latest. Now latest contains everything, so we don't need latest. Okay, so what I can do, I can just go to this Docker hub. Okay, go to this Python explore, and I'm just going to search for Python. Okay, and after searching for Python, what I'm going to do, I'm just going to search for some uh, small optimized base image. Okay, so Alpine is very very popular uh, base image which people use, and the best part of this Alpine is like this base image is of 5 MB, and after installing Python, it will be roughly around 50 MB, only 50 60 MB, something like that. So we can do that. We can decrease the size just using the right tag. Okay, now let's just run this Docker build my Vultr app, and this time I'm just going to write another thing, uh, optimize image. Okay, something like that, optimize. Okay, something like this. Now this will gonna create a new image, and this time it is optimized. Okay, let's see how it goes. It's taking time to deliver, but no worries. We're going to see that how much the size will gonna be. So it is 1.05 GB, and it is around 78 MB. Wow, around 90% or 95%, I think we had decreased the size of our image. Now it is optimized. Okay, now you can also decrease this image further with the help of some other tactics like multi-stage build, and then you have to remove the caches. You have to remove the library packages which you don't need them. So there are some few other steps which we have to do and understand, but that we cannot cover in just a 10 minute of time. But yeah, this is something which you can see after the session, that how you can optimize the size of Docker image, because if the size is decreased, then your performance will going to be increased, and of course efficiency and the reliability will going to increase simultaneously. So this is how the Docker will going to be helpful. Okay, and this is how you can utilize the Vultr platform in order to create the instance where you can run the Docker runtime to actually run your containers. Okay, so I hope you enjoyed this session, and if you have any kind of doubt, you can just write it down in the comment. And just remember, bookmark this GitHub repo where you can find all the resources. Okay, over here I provided some screenshots which you can also follow, like the steps to follow to create the instance. First step, second step, third step, fourth step, fifth steps. Wow, this is what you can do. Okay, and other than this, I've also provided the application source code. Okay, and other than this, I have provided the the Docker commands, some important Docker commands which might be helpful for you for future. So you can use it as a reference file where you can get all the important Docker commands all together in just one place. Okay. Then you got docker.pdf, which where you can find much more diagrams around different Docker concepts. Okay. And then you got this Docker PPT, which I have shown you. Okay. So this is how this thing works. Okay, before ending the session, I just want to cover one more last topic, which is CI/CD. So over here, one thing which you have to remember, mm, that in real time, what happens, like whenever you make the changes to your application, you know, uh, the CI/CD pipeline will going to create a new Docker image all the time. So the CI/CD tool is a very much important concept. If you're interested in DevOps, you can also explore the CI/CD steps and how you can use the Docker over there to utilize it in much more efficient way. Okay, so this is something which you can look after. So this is a slide which will going to give you a lot of story around the Docker. I hope this PPT and this different resources, whatever I'm providing, will going to be helpful for you. Okay, and this docker.sh, you can use this sh file to configure Docker to your Walter platform instance. Okay, super easy. Just make sure you're using Ubuntu platform because Ubuntu is Debian based and it supports apt. It supports, just a second, it supports apt package management. Okay, if you're using rpm based, you have to use yum instead of using apt. That's the simple difference between them. So this is all around Docker, and this is all around how you can run the containers on Walter platform. I hope you enjoy the session, and if you have any doubt, you can connect us. You can connect with the GFG team, and I hope this session gives you some knowledge around Docker and the workload, that how you can deploy the workload on this, Volta platform. Okay, that's for us today. Uh, that's Vedania. Goodbye. Take care, and meet you soon. Okay, keep learning, keep exploring, and stay motivated.